In a perfect world, one man stands alone.
You know, to some, doing things wrong is frowned upon. To me, it's a way of life. I come from a long line of wrongdoers. My father did it wrong. Just like his father before him. Someday, I hope to see my son grow up to do things wrong. Everyone is in such a big hurry these days. And I ain't gonna lie, doing things wrong takes time. Huh. Welcome back to Good Enough Garage. On this episode, we take a 10-minute job and turn it into an hour video. On a more serious note, on the last episode, we arranged our battery pack, or two BMW 530e battery packs, into one pack that will go in my truck. On this episode, we connect these two packs to the inverter, but we're going to do it one connection at a time. So what we'll have here, because we have two packs, we'll have two negative leads coming off of the pack and two positive leads coming off of the pack. And the reason I'm making this video is that I'm going to try to use one BMW safety box, aka contactor box, to achieve this, if possible. I don't know yet. What I plan on doing is having at least 3 videos. So this video is going to be on the negative connection. The next video is going to be on the positive connection. And the one after that will be talking about the safety box, the contactor box. So first, I just want to go over the components that we're going to be dealing with, okay? So obviously here we have the battery pack, and here, not so obviously, we have something called an inverter, okay? What is an inverter? Why do we have it here? All right, well, really what we're trying to do is send electricity from our battery pack to a motor. So let me get a model motor here, a little guy to symbolize what we're doing. Okay, so this is just for visual aid and some entertainment purposes. Here I have a motor, right? So let's just pretend that this is an AC motor. We cannot just directly connect a battery pack to an AC motor. We need something called an inverter. So we get this intermediary box here called an inverter, okay? And back in the day, folks would take DC motors out of electric forklifts, pull the motors out, go out and buy an aftermarket controller, tether the controller to that DC motor, and connect the throttle. And that's pretty much how we used to make EV conversions, okay? You can check out evalbum.com. I'll drop a link in the description and see some of the old school builds. However, OEM manufacturers, original equipment manufacturers, all the big boys, right? Toyotas, Lexus, Teslas, Nissans, they all now use AC motors instead of DC motors to power either hybrid or electric vehicles. Well, energy is stored inside a battery pack as DC, direct current, okay? The AC motor consumes alternating current. So we need a box to invert the DC into AC. That's why we get the inverter. Also, we can go the other direction. We can take AC and convert it to DC. That's what happens when we use regenerative braking. But I'm getting a bit ahead of myself. Bottom line is, when I say we're going to connect the battery pack to a motor, just assume that we're going to go through an inverter. So I might be using inverter and motor interchangeably, but you get the idea. The eventual connection is to the motor. So before we go any further, I just want to point out that there are two types of inverters or inverter setups. There's what I call remote inverters and integrated inverters. And Toyota and Lexus use what I call remote inverters, meaning that the inverter is housed underneath the hood of the vehicle, away from the motor, away from the transmission or the transaxle, which has the electric motors inside it. So you'll find these, not these, but similar orange cables running from the inverter to that motor. Whereas Tesla and Nissan Leaf integrate their inverters to the same unit, if you will. Tesla uses this barrel-shaped design, and when you look at something like the small drive unit or the large drive unit, LDU, what have you, that whole thing is not the motor. Only one side is the motor, and the other side, which also looks very similar to that barrel shape like the motor, that is actually the inverter. Inside there we have logic electronics and power electronics, the guts that live in here. And then if we look at Nissan Leaf, it uses what I call the pancake stack. And so again, it's all integrated, it's all designed as one unit. On the bottom we have the motor. It's mated with the transaxle, or it lives inside a transaxle. And then on top of that, the middle section is the inverter. There are no orange cables. It will unbolt, but it is connected via bus bars. So it's integrated to the motor. And on top of that, we have the charger, or what they call is the PDU, I think, power distribution unit, or PDM, power distribution module, something like that. Anyway, just wanted to get that out there. So we're dealing with a non-integrated inverter in my application, which is the Lexus GS450H, okay? And so we'll see a bunch of orange cables running from the pack to the inverter, and then a different set of orange cables from the inverter to the actual transmission, aka the motor. Come here, guys. I want to let you in on a little secret. I'm no expert, as if you thought I was. I'm just hacking my way through this, and I believe that sharing is caring. So I share what I've learned, I share what I stumbled over, and hopefully it helps somebody out, okay? Treat these videos as entertainment, okay? Be careful when you do this, use caution. This is dangerous stuff. It's high voltage, high amperage. But again, I mean, I'm joking here, but you know that I'm not an expert, okay? I just muddled my way through it, and I'm just sharing what I know. I'm sharing what you probably already know. All right, so in front of me, I have a BMW safety box. Sometimes we call it S-box for short. And this is what BMW calls a safety box. It is essentially a contactor box because contactors live inside of it. Think of safety box like saying ping pong versus table tennis, okay? Or Kleenex versus, I don't know, face tissue or nose tissue, okay? So one is just branded. So I got these packs out of two BMW 530e vehicles. Each pack of 6 modules came with its own safety box, a black box like this. I own 2 of these boxes. I want to send both packs now in parallel through one safety box if possible. I mentioned earlier that there's going to be multiple videos in this series. This is just doing the negative physical connection. The next video will be just doing the positive physical connection to this box, essentially combining 2 negative leads into one and then 2 positive leads into the other. Will this box handle what I'm doing? I don't know. We'll get to that in the third video. Will it maybe require some upgrades? Maybe. Again, we'll get to that in the video on the safety box. Just to let you know, I already have 1 or 2 safety box videos out there. I believe in one, I take one apart, and in another one, I take it also apart. So look in the history, look in the BMW playlist, because you'll find me working with these modules and working with these safety boxes and blowing one of these into 1,000 pieces. All right, so I keep repeating myself that this is a contactor box. So what lives in there? Well, obviously contactors. So these orange little boxes here are contactors. I think of contactors as nothing more than automotive relays on steroids. So whereas your automotive 4-pin, 5-pin, dime a dozen relay can handle 12 volts and about 40 amps, up to 40 amps in your vehicle, these guys are bulkier. They can handle 400 volts out of that pack, and they can handle higher currents, 200 amps, 300 amps, what have you. I'm going to start throwing some actual specs at you. I know there's a video on the safety box coming up, but rather than bombarding you with a ton of information in that last video, I'm going to try to pepper it in and kind of spray it in there gently. So these orange contactors are rated for 175 amps, okay? I believe it says on here 500 volts and 175 amps. So just put that in the back of your noggin, all right? These modules are what I call the second generation 530E. Prior to this gen, which is 12 kilowatt hours, each one of these 2 packs is 12 kilowatt hours. BMW made the first gen, which was 9 kilowatt hours. It also had a safety box just like this. But inside of that box, the contactors that lived in there looked like this, okay? They were black, but they were also rated at only 120 amps. I don't see how many volts these were. We really care more about the amps, I think, than the volts at this point. So BMW upgraded their contactors. They went from 120 in the first gen 530E battery packs to now 175, okay? And it's important that you kind of start paying attention to these numbers to get an idea, right? It just car specs. We're in a new era of electric vehicles, so instead of talking about cam lobes and lifts and degreeing the cam, now we're talking about volts and amps and resistors and what have yous. So we went from the BMW 120 amps, then the 175. Here is a contactor that looks awfully similar to the BMW one. They're both by Panasonic. This one is out of a Nissan Leaf 100% electric vehicle. This one is rated for 200 amps. So in my old box, I was planning on upgrading the 120 amp contactors to 200 amp contactors. Can this pack deliver more than 120 amps? Yes. Can it deliver more than 175 amps? Yes. Can it deliver more than 120 amps? Yes. We'll discuss all that in the third video, which is going to be about the safety box. For now, contactor box that has these little dudes in it. Speaking of contactors, some of them look like are cylindrical, so they look like this, okay? But if you roll your own contactor box, you may be using these guys, okay? So I think these are actually by TE, whatever that stands for, it's the manufacturer, same thing as this, TE is the manufacturer. Put down in the comments if you remember what it stands for. But yeah, so here it has black fat cables on it because this was probably a negative contactor. I have one just like it that has orange or red cables because that was used to be the positive contactor. Okay, so just to review, we want to connect this battery pack to an AC motor. but we can't directly. We have to use an intermediary, this box called an inverter. And then we find out we can't even connect to the inverter directly because we need to use something called a safety box or a contactor box. Why? What's going on here? Okay, so again, I am going to talk about all this in more depth in the third video of this series, the safety box video, but I will touch on some of the stuff, especially in this video when it pertains to the negative lead. In the last video, we covered all these orange cables for the 5 orange cables that it takes to connect the modules to each other. And then I wrapped up the video by showing you that there are going to be these 2 extremely long original cables that were the negative leads for each pack. And the negative leads on these packs ran from the number 1 module, which is this guy right here at the other end. You can't see it on the camera, but that's okay. So that's what we're going to be working with here. I'm going to put one of these negative cables away just for now and only use one to demonstrate something. Okay, so let's pretend that I plug in one end to module 1 negative, okay? I'm not going to do it just to be safer, but let's just pretend it's connected. All right, so we're learning this very, very basics of EV conversions of electric vehicles. Certain things we just buy into and we assume, fine, we need an inverter. Well, let's connect the battery pack to the inverter. So we go ahead and we connect, either directly to the inverter. Here I'm just demonstrating with the leads just because I have them. And then I'm going to grab another cable here. This pack uses shorter cables for the number 6 positive. So I'm just going to use one. Again, there will be 2 of these, but I'm just going to use one just to kind of symbolize something here. So again, this is connected to the pack on that end. And then we connect these to the inverter. Simple, right? Fat orange cables to an inverter, and the inverter goes boom. We have what they call the black magic smoke, right? We just blew up the inverter. More precisely, we just blew up the capacitor inside of this inverter. I'm going to just spread these out a little bit. Okay, so let's just pretend we're disconnecting it. So we can't do that. We can't just directly connect our battery pack to the inverter because we'll blow up the capacitor. Now, I think of capacitors as just very fast, super thirsty batteries, okay? That's oversimplification, but just go with me. And if you're a computer nerd like I am, then we can use the analogy that a battery pack is like a hard drive, what we used to call a disk drive, hard disk. Back in the day when they were not solid state, we actually had these bricks, these metal bricks that stored data, and there were plates inside there that spun, okay? So they were mechanical. They were big, they were slow, but they could store a lot of data. Our packs are big, they are slow, and they can store a lot of energy. A capacitor would be the equivalent of RAM, random access memory, right? Like your DIMMs, your SIMs, whatever they're called today, right? So a capacitor is more like memory. The memory in your computer is smaller, it's way faster, okay? So the cap is faster for pulling and discharging energy, all right? And that's the analogy that I use for it. Cap is like your RAM, and your battery pack is like your hard drive. Okay, so if we connect the pack directly to the cap, it's going to act like a water balloon when you're getting ready for a water balloon fight. Have any of you ever been in a water balloon fight? You take your balloons, you run up to the kitchen faucet when mom's not looking, you strap on the balloon to the faucet, you turn on the spout, and if you do it too fast, the balloon just blows up, okay? Too much water rushes into that balloon too fast and it blows up. Same thing happens with the capacitor inside this inverter. But if you take that balloon and you put it on the faucet and you slowly turn on the water and trickle in some water, trickle in some electricity into the cap, then it sort of warms up and fills up slowly, and then it will not blow up. So that will be discussed in the third video in further detail. But this is one reason why we cannot make a direct connection, okay? Let's think of another reason. If we for somehow took care of the cap, prevented it from blowing up, what is another downside to having a permanent, which I would call a hardwired connection to our inverter from the battery pack? Well, it's dangerous. Think about it. In some applications, your battery pack lives in the back of the vehicle, let's say in the trunk of your vehicle. These orange cables run the length of the car, either through the cab or underneath the vehicle, all the way to the front where your inverter lives, to the motor, and all of this stuff is always live. Now, you wouldn't do this, but I'm just giving you an example. So the other reason is that these would be dangerous, okay? These would be live. In electric cars, these wires that run underneath the cars, like your Nissan Leafs and the Teslas, what have you, they're not live until you start the vehicle and you're ready to drive. That's when the safety box does its job, and we'll learn what it's doing in a third video, but it essentially turns on the battery pack and allows the energy to come out. Normally, when you approach an electric car that's just sitting there, there is no electricity in these orange cables until you're driving. We can also argue that point for in terms of charging, but we're not going to go there. We're just focusing on driving. That was one of the things that surprised me when I first got into this sport, right? I thought electricity just is going to it, like power lines. You know, these things are delivering electricity to this inverter. But no, you can't take a multimeter and touch the leads on the battery pack, because the safety box that lives inside the battery pack has the battery pack turned off, if you will, okay? All right, so for safety reason, we cannot have a hard connection. And can you think of a third reason, okay? This one is a little bit sneaky and tricky. I learned about this the hard way. So because we have a capacitor in here, when we turn off the vehicle, it needs a little helper to drain the energy that's stored inside of it. And so there is what I call a bleed down resistor. I don't know what the technical term is, but I believe there's a resistor inside this box that drains slowly the energy out of the capacitor to make it safer and depletes it of that energy. So if we have a permanent connection here, but our car isn't turned on, so the inverter, it's an electric component, it runs off of low voltage, like 12 volts. So when we turn the key on in our vehicle, we actually send electricity, low voltage, to this box to power up its logic electronics, right? Its logic board and so on, its brain. Well, when it's not powered on, that little resistor is constantly bleeding down that cap, but the cap is pulling from the battery pack, so it's just slowly draining. Now, it's not going to drain your pack in an hour or maybe even in a day, but if you leave it like that, it's constantly draining the battery. So those are the three reasons, okay? One is if we do a direct connection, it's going to blow up the capacitor. Two, if we do a direct connection, it's hardwired, it's dangerous for us to touch and what have you. And then the third is there's a bleed down resistor in there that's draining the cap. And that's why we don't want a permanent hardwired connection. Okay, so rather than just telling you how this problem is solved, we're going to struggle through it and muddle through it together and build on our knowledge to see how we can get through this problem of not having a hardwired connection from the pack to the inverter. And so, all right, we somehow need to break this connection and control it. Okay, well, let's use a switch. So obviously it's not going to be like a light switch, but this is the general idea. It's going to be like a lever. And we're going to put down the lever at least on one of the leads. Let's say we put it on the negative lead. We could also have a second one on the positive lead. And when you think of the contactors, that's all they are. They're just electric switches. There's one on the positive lead, there's one on the negative lead. So inside that box, this is what's happening, right? There are these contactors. One is on the positive lead, one's on the negative lead, okay? Something like this, right? And our safety box controls them with some logic. But we're not there yet. We're building up to this point. So what we do is we're going to say we're going to put these types of manual switches, okay? Pretend there's two of them, one on the positive, one on the negative, okay? So for convenience, we put them right next to the shifter, right next to our handbrake in the car. Now we get in the car and we're like, ha, problem solved. We don't have a live connection. We have these switches. Okay, we're ready to drive. So, turn a switch, which turns on an inverter, and then we flip the negative switch, and then we flip the positive switch. And for the time being, we're going to assume that the capacitor doesn't go boom because we have the mechanism called the pre-charge circuit that takes care of it like that water balloon, and so it won't blow up. I want to focus on the positive and negative leads here. So we did the switches. So can you see a problem with this solution? One issue is that for our convenience as humans, we want to have these switches close to us. So they're in the cockpit, right? They might be on the dash, or they might be between the seats. And now we're still sending at least half the length of the car, high current, high voltage, to these switches, right? So we kind of kick the can down the road. It's still freaking dangerous, okay? The other way to do this will be to put them inside the pack where the safety box lives. But now we get in the car and we start the car, if you will, and we're like, shit, get out of the car, walk over to the trunk of the car, flip the negative switch, flip the positive switch, walk back to the car, get in, all right, let's ready to drive. It's not practical, right? But this is the idea that these contactors are nothing more than switches. And so what I want to demonstrate here is that the contactors inside the safety box do that for us remotely. They're sort of like remote controls for us. When we start the car, we close the negative contactor. Then as some more logic takes place, which we'll talk about in the third video, the positive contactor gets closed, okay? Yes, there's a pre-charge circuit involved. That's a little bit more of an advanced topic. We'll get to it. I just want to demonstrate to you that that's what the contactors are doing. They're nothing more than mechanical switches that are essentially driven by coils and electronics, all right? Okay, so now this is what our solution inside of that safety box looks like, right? There's a negative lead going to the negative contactor and a positive lead going to a positive contactor. And these contactors live inside the safety box. So now I'm going to slide over the inverter, bring out the contactor box, and now we finally start talking what this video is supposed to about, tying in the two negative leads into one to connect to that contactor box, which only has input for one negative lead and which only has input for one positive lead from the pack. Okay guys, so half an hour into this video, here we are finally trying to do what I set out to do. So let me show you the 4 connections on this safety box. 2 of them are output that run to the inverter, and then 2 of them are input from the battery pack. So I'm going to bring you in here closer. First I'll kind of show you how these connect from far away, and then I'm going to bring you guys closer. Okay, so first we're just going to do the output here. Okay, so positive and negative on the outside. I'm not going to snap them in because, again, they're kind of hard to take out. Those run to the inverter, and then we would normally have one negative coming in here, and this box is kind of funky, so I can't connect them this way because they're keyed. They all go in this way. So then here is the negative. If you work with this box, you know you have to really pay attention because these connections are kind of convoluted. The output positive is here, but the input negative is right next to it. And on this side, the output negative is here, and the input positive will go next to this guy. Anyway, that's neither here or there. So the problem is that we only have one negative input, and we have to run 2 leads into that one connection, okay? So let me show you how I plan on doing that. But first, I'm just going to bring you a bit in here to show you these connections. All right, I hope you guys can see this better now. You can see what these connections look like, okay? They're proprietary. I don't know if we can even buy these aftermarket somewhere or if we would want to. So I wish these were just screw-on ring terminals, but they are not, and it's for a reason, you know, it's so that we don't muck with this stuff for our own safety. But here I am mucking with it. So this box is labeled, so on the outside this says positive, and the outside this says negative. The way I remember these connections is, again, that the outside ones are output and the inside ones are input. So first I'm just going to show you again the output. Notice how you shrink wrap on here to tell me that this runs not only to the inverter but that this is positive, right? And on this side it just says box for safety box. So this is going to snap in here. And then the negative lead, again, still from the inverter. Let's see, show you guys what I'm pulling from. Toolbox on wheels, great. Sounded like a good idea. Okay, here we go. And then the negative one goes here. So at this point, this is safe to play with because there's no energy going to the safety box. We're just connecting some leads to the inverter. The capacitor inside the inverter has been drained, and here the safety box is just, we're just connecting to the safety box. No big whoop. So these are our output, okay? So what we're concerned with is this negative input. I have two of these proprietary leads that need to merge together and plug into this one opening here. So I'm going to show you how I plan on doing that. Now there's a couple ways you can do this, okay? I could cut maybe 6 inches or a foot off of one of these and just cut the end off of the other, connect them together, and then use that longer 1 foot lead to run sort of a T into here. So I'm not going to do that. I'm actually going to cut off about 1.5 inches of each one of these. It is kind of wasteful. These cables are about $70 each. They're the longest ones in the pack, but I need all the length I can get on my implementation. And also, since I own the BMW 330e battery pack as well, from there I have the equivalent lead. It had a shorty from 1 negative. Can we see that? I don't even know what is going on. That should have, I don't know why you guys can't see that 1 negative. There it is. 1 negative, and that runs to S negative, which is safety box negative. So it had this really short lead. I'm going to cut another end off of this about 1.5 inches away, and I'll show you what I'll do with these ends, these shorties. They will not go to waste. But basically it's going to be these two into this one, and then that will plug into my safety box, okay? So stay tuned, and this is going to make more sense once I clear up this workbench a bit. All over but the crying. First $70 mistake. Let's hope that's not the second $70 mistake. and our little stubby. All right, guys, you are going to now see the headless EV converter for the rest of the video. So one of the first things I noticed about cutting these cables is that these are not a single wire or single cable. They're actually two, okay? Two smaller gauge ones side by side. This allows them to get some flatability out of it, I guess. Anyway, this is just how they did it. So because these are two into one, I'm just going to keep them as two, and I'll show you the ring terminals that I plan on putting on these. So here we go. These are pretty darn hefty, okay? These are going to be mechanical connections. It says, I think it says 6-16 on here. Okay, whatever that means, AUG or gauge, I guess. So I'm going to use 2 terminals per cable, or then per wire or whatever, for each individual one. I think these will fit. We'll give it a try. But before I even do that, I'm going to mark all these connections with some black conduit. I could just use electrical tape, but I happen to have some nice shrink wrap, or whatever it's called, heat shrink. So we'll see if I can slide these on there, and this is just to allow me to mark them, really, just so I know, okay, I think these are going to be a bit too tight, so let me get something a little bit bigger. Okay, so here I have some pretty heavy duty heat shrink, actually, and let me see if this is bigger. It's a little bit bigger. I'm going to try to use one that is just big enough to slide on here. I don't want to go too big with anything. See if this one would work. It's kind of tricky because now these are frayed. I might put some tape on them first and then slip these on. Or I might just go with a bigger size. Let's see here. Yeah, I may just do this. Okay, let me cut a few ends off of this guy. Okay, this is just going to be used as marking to tell me that these are negative at a glance. And then we'll get back to our regular scheduled programming here. Okay. All right, so, okay, well, whatever. We'll start with this guy. Can I get that on there and not look completely ridiculous? Okay, so here's the general idea, okay? I'm gonna use my heat gun on here, and I'm just marking this end as negative, okay? That's all I'm gonna do here. Yes, all my tools are yellow, and the Walter White here is no exception. This one goes up to 1100, that is. It takes a minute to warm up. I'm gonna see if I can slip on another one while that's warming up. I'm just too lazy to do it right and put some tape on the end. No big deal. Okay. And then one more. Oh, come on, you. Okay. We'll just slide it to the end. These are all our negative. And here you just gotta stay off of the orange because that will sort of melt. And as long as you're moving around, it should be okay. And this is just for marking, so I'm not really trying to protect anything like that. Just sort of keep the gun moving, right? Keep gun here. Okay, so now at a glance we'll know, okay, these are our negatives. Okay. We just mark. I don't know why high voltage wires aren't marked. Okay, I don't know why they're always just orange. I mean, yes, on the ends here, they'll put down like one negative, one positive, but why isn't this just like red, the whole thing, and the other one black? I just don't get it. Okay, so now I'm going to use a razor blade to strip off these ends about an inch or so to have the terminals go on there. And then I think I'll shrink wrap these individually plus the one whole big section. So let me start that. Okay, maybe I'll slip one of these on first. Just kind of winging it here as I go, gentlemen. Oh, come on. There we go. So I'm just going to slip that on for good measure. These will need much smaller ones, I think. Okay, let's see. Yeah, I think something like this could work. I'm not sure if I even need to have them be so long, but whatever. Okay. All right, so now I'm going to strip about an inch off of these. Okay. And then shove them into here. This gets exponentially more difficult when the camera is rolling. Okay, I have a straggler here, so I'm just going to snip it. Should be good enough. That to me looks pretty darn good. Another yellow tool, folks. So here I have size 25, whatever that is. And got this stuff on Amazon, so it's gotta be good. So this is a fantastic tool if you have 3 hands. See what I mean? You need 3 hands because it's like you want make sure it doesn't slip out of there, but then you got to pump it and then you got to hold the thing. Okay. You just go squishing it till there's no gap. That ain't too shabby. Okay, so it's just gonna go like that. That should work. I am afraid to pull on this. I think that's good. I'm gonna do this other one and then I'll heat shrink them both just so that the heat doesn't pre-shrink this one prematurely, if you will. Okay, let's keep going. After this other one, I will probably time lapse or just jump you to later in the video. No reason for you guys to suffer. Tell us a Chuck Norris joke, somebody. Don't be shy. Might even have time for 2 Norris jokes. Yeah, this part is tedious. And I'm sure there is a better way to do this. Trying to use the smallest lugs possible here, though. And not just take the easy way out and go with some ones that are way oversized. Alright guys, I got the second one on there. Took some doing. Now we're gonna try to populate it. Probably put this in some sort of vise or something. But here we go. So when crimping these, we don't use solder because this is high amperage and supposedly it's going to melt it. So we do these mechanical connections, which just mean like brute force, I guess. Ugh. Okay, so we just do it like that. When doing something where this part is about 1 inch, but the crimp jaws, you can see that are only about 1/3 of it, or half or something like that, then I like to do it towards the end so that the ends fray at the end and sort of create this tight connection that won't slide back, right? Okay, so now we're gonna put the shrink wrap on here on each individual one, and then we're going to shrink wrap both of them together and go from there. So let's do that. All right, here we go. So I hold them this way so gravity kind of pulls them down a bit because they are shrinking shorter now. And I know I'm doing it wrong. Okay. I know there's probably 7 different ways to crack an egg. I don't think these are too shabby, ladies and gentlemen. I don't think these are too shabby. All right. Now we're going to pull this down. And I'm going to maybe something like that. It may be wise to first kind of connect them. Let me show you. I may want to connect them like this, kind of back to back, and then shrink wrap them that way so they hold. We'll see what happens. All right. See what I'm doing there? Okay, and now I'm going to try to shrinkitize this. So not only does this shrink and get tighter, but I think this one has glue inside of it too. Some sort of adhesive. Okay, I'm gonna make, this is one, I need to make another one just like this, okay? This goes from the negative terminal on this end to the safety box T on this end. Let me go ahead and make the other one just like it and the shorty, and then I'll show you how I plan on joining them all up. All right, guys, so I muddled through these and I made all the 3 connections. So now we have ring terminals on them. And first I'm going to show you the general idea. So don't throw any tomatoes on the screen till you see the whole thing, okay? So this here, all right, so this is the general idea, right? It's a Y connection, but I prefer to call it like a T connection, and I'll show you why, okay? This end's going to plug in, obviously, to our safety box. And this is okay-ish if we were stranded on a deserted island and weren't afraid of getting shocked and killed by the electricity. But there's a better way. So I'm going to run to Home Depot real quick, and I'll be right back. So here I have one of these conduits, a T connection, T-type. And this is actually, believe it or not, from the electrical aisle at Home Depot and not from the plumbing aisle for once. Okay, so it comes with a handy-dandy gasket here. It might be even weatherproof, who knows? So we're going to shove that in there. These things here I'm just using as reducers to make the hull a little bit tighter. And I am going to probably use shrink wrap over the whole thing eventually. But, you know, we're prototyping here, folks, aka half-assing it. So let's see. I know that without the reducers, these fit quite easily and nicely, okay? But, you know, I'm going to try to do it the harder way and try to put in the reducers as well. So first I'll just slip these on there so that I can have some wiggability. I might feed through this one first and then just stack these on top. I don't think it matters, it's just that one of these this bolt is long and I don't have that much wiggability in this short cable as I do in these. So let's see if I can have better luck this way. I'm just trying to get them in there. Come on. Ha! Okay. 2/3 of the way there. This is still on there. Alrighty. Uno más. Okay. So now I think it gets even more exciting with this. Move this over. Struggle is real. It's almost in there. Are any of you guys old enough to remember ships in a bottle? That whole craze? You guys remember that? That's what I'm doing here. Now, I never built one of those ships. I probably should have. Sometimes it's just some gentle brute force is all it takes. Now, I am going to put a locking washer on there eventually. See what we're getting there? I love it. Okay, I'm going to zippity-doo that with a bzz, bzz. Another yellow tool. 7/16. We're going with American here. Oh, that, come on. All the dads watching, say it with me now. That ain't going anywhere. All right, now we stick these in there. And this isn't perfectly watertight yet. I can build up the insulator thingy bobbers here, but this is a prototype. So we're gonna, there it goes. Some gentle persuasion and we're in. Love it. And I am going to take great pleasure in putting this on. Just a thing of beauty. I love putting on the finishing touches. All right. So the point of this thing is just to keep idiots like me from touching the high voltage, high current connection, right? But guys, I am really happy with this, okay? I would love to hear from you in the comments why you think this isn't gonna work, but I'm gonna run with it. So I'm gonna zoom out the camera and show you how this is all gonna connect now to the safety box. Okay, we set out in this video to make the negative connection from the battery pack to the safety box. And I think I've achieved that. I apologize for a ton of information I shared with you before doing this, but I wanted you guys to kind of see the big picture, and now we can kind of focus in on the details of it. So here we go. Again, this is the safety box, BMW safety box. It has 4 connections. The outside ones are output, the inside ones are input from the battery pack. And I believe this one goes right here. Oh, that's beautiful. So I am really happy with that, okay? The outputs I showed you already, those run to the inverter. But this is kind of the idea. Now, some of the concerns we may have is that, look, I'm running this type of gauge here. I'm pulling from both packs, doubling the current, and then I'm running it through this dinky nonsense right here. Will this overheat? Will this melt? Will it catch the truck on fire? I don't know. I know that this is very short, and when it comes to cabling, you know, you can increase the gauge, the thickness of the wire, or you can shorten the distance, right? I mean, this is really short. I might even go shorter and cut it in half, but I'm just gonna call it a prototype and drive the truck. Thanks for watching, guys.